In this lesson, we're going to learn all about transformers. Not the Optimus Prime kind, sadly. A transformer is used to step up or step down the voltage in an AC electrical circuit. Now, it's important to remember that a transformer only works with alternating current because it requires a change in the magnetic field to produce a change in the voltage. In direct current, the magnetic field is constant and therefore no potential difference is induced, so it simply does not work. Now, the basic structure of a transformer is as we can see here. We have a soft iron core with two coils of copper wire wound up on each side, where one is called the primary coil, while the other is the secondary coil. There are fewer turns in the primary coil as we can see, and it is also connected to an AC power supply. There are more turns in the secondary coil. To be precise, there are 5 turns in the primary one and 10 turns in the secondary one. This makes it a step-up transformer. When the alternating current from the power supply flows through the primary coil, it generates a change in the magnetic field. It's when the magnetic field passes through the secondary coil, a potential difference or voltage is induced. Now, the potential difference that is induced is dependent on the number of turns of the primary and secondary coils, as you can imagine. To step up the potential difference, the number of turns in the secondary coil must be greater than the number of turns in the primary coil. This makes sense since we are going from a lower amount of turns to a greater amount of turns, as is the case here. And vice versa, to step down the potential difference, the number of turns in the secondary coil must be lower than the number of turns in the primary coil, which again makes sense since we are going from a greater amount of turns to a lower amount of turns. In our example here, we have a step-up transformer as we are going from 5 to 10 turns. So, as we have already discussed, the potential difference produced in a transformer is directly related to the number of turns in the primary and secondary coils. The relationship between the number of turns and the voltage is the equation shown on the screen. So the number of turns in the primary coil divided by the number of turns in the secondary coil is equal to the voltage at the primary coil divided by the voltage at the secondary coil. The equation basically states that the number of turns and the voltage induced is in the same ratio. The number of turns in the primary coil and the number of turns in the secondary coil is directly proportional to the voltage. So, for example, in our transformer here, the number of turns in the primary coil is 5, while the number of turns in the secondary coil is 10. So, in this particular scenario, we can say that this is a step-up transformer since we are going from a lower number of turns to a higher number of turns. If the primary coil produces a potential difference of 100 volts, then the secondary coil in the same ratio would produce a voltage of 200 volts, as it has twice the amount of turns. Now we can see this relationship in action by the calculations shown.